Modeling planet Earth. Here are our learning goals for today. Explain why we use latitude and longitude. Define the terms latitude, longitude, prime meridian, equator, and hemispheres, and be able to find them on a map or globe. Describe the axis and rotation of the Earth, and explain the time zones and international dateline. A model is when you make an artificial representation of a real-world object. And people have done that for centuries. One model of the planet Earth are globes. Globes are three-dimensional. They're very accurate, but they're not very portable. If you were going to go somewhere in your car, you wouldn't bring a globe along with you. Even though it's very accurate, it'd be hard to use. Maps are two-dimensional. They're very portable. You can fold them up, put them in your pocket, but they're not as accurate as globes. Maps are made by what we call map projections. Because they're two-dimensional, maps produce distortions. Think about trying to wrap a piece of paper around a globe. It just doesn't work very well. So different projections of the Earth's surface produce maps that accurately depict only a portion of the Earth's surface, but not the entire Earth. The most common map projection is called a Mercator projection. This is the common map that you've seen in classrooms in different places. It's accurate for this part of the globe, but it produces distortions as you get toward the poles. It makes Greenland look enormous, and Antarctica even bigger. In fact, Antarctica is not as big as the United States, but it looks like it's bigger than all the other land masses on Earth when you use this projection. The most accurate projection is called a polyconic projection, and it's especially accurate for the middle latitudes. That's the part of the Earth in this area, and that's where most of the land masses of the Earth are. So a polyconic is the preferred map projection. Push pause, answer the questions, and when you're ready, hit play. Why do maps cause distortion when trying to represent the surface of the Earth? Well, maps are two-dimensional and the Earth is three-dimensional. Which type of map projection is the most accurate for representing the middle latitudes? That would be a polyconic map projection. Latitude and longitude are imaginary lines on the surface of the Earth, and they produce a grid which gives every point on Earth a unique address. Here's a blank globe with lines of latitude and longitude on it. Let's take longitude lines first. Longitude lines are half circles that run from pole to pole. They're also called meridians. So here we see a globe with lines of longitude on it. They run from pole to pole. You notice that at the poles they're very close together, but at the equator they're very far apart. If you were at the North Pole, you could run around the North Pole and cross every line of longitude in a matter of seconds. You can't do that at the equator. We use lines of longitude to divide the Earth into hemispheres. The prime meridian divides the Earth into eastern and western hemispheres, and the prime meridian runs through Greenwich, England. So here, the dark line is the prime meridian. If we go east from there, this is the eastern hemisphere, and if we go west from there, it's the western hemisphere. There are 24 standard meridians or lines of longitude that are 15 degrees apart, and we label them east, going east from the prime meridian until we reach 180 degrees, and we label them west, going west from the prime meridian until we reach 180 degrees again. So here's our globe again. Here's the prime meridian. If we go east, we're in the eastern hemisphere, so we label the lines of longitude east. So this is 15 degrees east, 30 degrees east, 45 degrees east, 60 degrees east, and so forth until we reach 180 degrees. If we go west from the prime meridian, then we label them west. So this would be 15 degrees west, 30 degrees west, 45 degrees west, and so forth, because we're in the western hemisphere. Lines of latitude are complete circles that go from east to west, and they're parallel to the equators. So we call them parallels because they're parallel to each other. So here's lines of latitude. They're complete circles. They go all the way around the Earth. They're parallel to each other and parallel to the equator. The Earth is divided into northern and southern hemispheres by the equator. So if we go north from the equator, this is the northern hemisphere. If we go south, it's the southern hemisphere. There are 11 lines of standard latitude 15 degrees apart. So if we start at the equator, which is 0, and we go north, this is 15 degrees north, 30 degrees north, 45 degrees north, 60 degrees north, 75 degrees north, and finally the North Pole is 90 degrees north. We have the same thing going south, with the South Pole being 90 degrees south. So here are the lines of longitude, half circles that run from pole to pole. They're not parallel to each other. And here are lines of latitude, complete circles that go all the way around the Earth and are parallel to each other and parallel to the equator. People have trouble remembering which direction the lines of latitude and longitude run. One way that I help myself remember is think of lines of latitude like rungs on a ladder. The rungs on the ladder are parallel to each other. And the way I help remember lines of longitude is I think of a peeled orange. It's divided into sections that run from the top of the orange to the bottom of the orange. So hopefully that'll help you keep them straight. If we put everything together, then this is what the globe would look like. Here's the prime meridian. As we go west from the prime meridian, these up and down lines are lines of longitude. This is 15 degrees west, 30 degrees west, and so forth. Here's the equator. The lines of latitude are parallel to the equator and are full circles that run all the way around the Earth. So hit pause, answer these questions, and then hit play. Lines of longitude run from pole to pole. What is another name for lines of longitude? That would be meridians. What is the name of the line of longitude that divides the Earth into eastern and western hemispheres? That would be the prime meridian, 0 degrees longitude, that goes through Greenwich, England. What is another name for lines of latitude? Well, those are parallels because they're parallel to each other. Which line of latitude divides the Earth into northern and southern hemispheres? That would be the equator. Are lines of longitude or lines of latitude complete circles? Lines of latitude are complete circles. Lines of longitude are half circles. All right, let's put into practice what we've learned. What is the point in latitude and longitude that the red arrow is pointing to? That would be 0 degrees latitude, 90 degrees west longitude. So this point is on the equator, 0 degrees latitude, and it's 90 degrees west of the prime meridian at 0. Let's do another one. This point is 0 degrees latitude, 0 degrees longitude. It's on the equator, and this is the prime meridian. So it's 0 degrees latitude, 0 degrees longitude. How about this one? That's 30 degrees north latitude and 30 degrees west longitude. How about this one? That would be 60 degrees south latitude, 90 degrees east longitude. Here's the 90-degree longitude line. Here's the 60 degrees south latitude line. Let's talk about Earth rotation and time zones. The Earth rotates once every 24 hours from east to west on an axis that runs from pole to pole. Everybody knows that. Because of that, the sun rises and sets at different times in different locations because of the Earth's rotation. So when it's sunrise here in the east, it's still dark in the west. Now, in the olden days, people determined the time by when the sun was highest in the sky. They called that noon. So noon is a different time for every place on Earth. And back in George Washington's time, he would keep time at his plantation by when the sun was directly overhead. He would call that noon. If you were in Manassas, you would have a different time for noon. Well, back in those days, before there were telephones, telegraphs, railroad trains, things like that, it didn't really matter. If you said noon was one time and Manassas said it was noon 10 minutes later, it really didn't make any difference. But with the advent of railroads and telegraphs, we had to have a standard way of determining what the time was. So time zones were created to standardize time over large areas of the country. So each time zone is centered on a line of longitude 15 degrees apart called time meridians. Right? So the standard meridians are also time meridians. This is one time zone, this would be another time zone, and so forth. There are 24 time zone meridians. If you divide 360, which is the number of degrees in a circle, by 24, you get 15 degrees. There are 24 hours in a day, so the sun passes over one of these meridians each hour. The international date line is the 180th meridian. At some point, we have to separate one day from the next, and the international date line is the way we do that. On one side of the international date line, it might be December 1st. On the other side, it's December 2nd. Hit pause, answer the questions, and then hit play. What is another name for lines of longitude that mark the standard time zones? Time meridians. Why do we have standard time zones? It makes it convenient in the modern day that everybody uses the same time. What is the name of the line of longitude that separates one date from the next? It's called the international date line. Which meridian in degrees is the line of longitude that separates one date from the next? Well, that's the international date line, which is 180 degrees longitude.